What if humanity actually tries to colonize Mars? Not send a rover, not a temporary mission, a permanent human civilization. At first, it sounds like a sci fi dream, but the moment scientists started calculating the physics, the fantasy became terrifying. Because Mars is not just far away, it is separated from Earth by one of the most hostile environments imaginable, space itself. And for the first time in human history, survival would depend entirely on machines. Every breath, every drop of water, every watt of electricity, every single second of human life would exist as long as the machines continue functioning perfectly. And that changes everything. But if Mars is that difficult to survive on, why Mars? Because among every planet in the solar system, Mars is the least impossible. It has a day almost the same length as Earth. It has polar ice. It has seasons. And buried beneath its surface, enormous amounts of frozen water. But even then, Mars is still brutally hostile. The atmosphere is 100 times thinner than Earth's. Temperatures can fall below minus 150 degrees of Fahrenheit, and the entire planet is constantly bombarded by radiation. The soil itself contains toxic chemicals called perchlorates. But before we think about surviving on Mars, we first have to survive the journey. And that journey is far more dangerous than most people realize. At closest approach, Mars sits around 34 million miles away from Earth. The distance can grow to over 250 million miles. That means a Mars mission cannot simply launch whenever we want. We must wait for planetary alignment windows when Mars and Earth align perfectly, appearing only once every 26 months. But even with perfect timing, it takes around 6 to 9 months to reach Mars. Now, imagine the reality. You are trapped inside a tiny metal can for 9 agonizing months in deep space. No fresh air, no resupplies, no emergency landing, no rescue. Once you leave the Earth, you are completely alone. Even a simple message takes over 20 minutes to reach Earth. That means no real-time help. You must solve problems yourself, millions of miles away from home. But before you even worry about the isolation, you must cross the void. Earth's gravity. To escape it, a spacecraft must reach over 25,000 miles per hour. Reaching that speed requires gigantic engines burning fuel at absurd rates. That's why rockets look so strange, because most of it is fuel, and during launch, a rocket can burn several tons of propellant every single second. Let's take an example. In the 1960s, NASA's Saturn V moon rocket burnt over 3,300 gallons of fuel every single second and burnt over 530,000 gallons of propellant in its first stage of 150 seconds. And that makes combustion temperatures inside rocket engines exceed thousands of degrees. Fuel pumps spin at insane speeds. Turbines generate enormous pressure, and the entire structure experiences brutal vibration. For a few minutes, the rocket essentially becomes a controlled explosion. Somehow, engineers keep it stable. The rocket successfully launches and escapes Earth's gravity. But the moment it reaches the space, the real engineering challenge begins. A car moves by pushing against the road. A plane moves by pushing against air. But space contains almost nothing. So, how do you move forward in a vacuum? To make it move, engineers discovered a brutal physics hack: rocket propulsion. A rocket engine creates controlled explosions, throwing hot exhaust gases backward at extreme speed, and the spacecraft is pushed forward. But generating enormous thrust requires enormous propellant, and more fuel means more weight. More weight means more thrust. So, rockets get trapped in a brutal cycle. To break this cycle, engineers invented a genius solution: throwing parts of the rocket away, called multi-stage rockets. Once a fuel tank empties, the entire section detaches and falls back to Earth, making the spacecraft lighter, allowing it to accelerate more efficiently in the next stage. Modern space travel would barely be possible without staging. This is why massive rockets slowly tear themselves apart, stage by stage, section by section, to remove the dead weight. Even then, every pound still matters. A single unnecessary component can affect the entire mission. Now, imagine the situation. You are trapped inside one of the deadliest environments possible. Cosmic radiation constantly passes through the spacecraft. No fresh breathable air, no rescue missions, no hospitals. So even tiny mistakes become catastrophic. A microscopic crack, a failed valve, a broken oxygen system. Any of these could kill you millions of miles away from home. And if all of these work perfectly, there is another terrifying problem to face: human biology itself. Our bodies are designed for Earth's gravity. In deep space, there is no gravity. So, muscles start to weaken, bones lose density, vision shifts, the heart slowly adapts to weightlessness. You must constantly exercise to stop your body from deteriorating. And if you handle all of these, the psychological isolation is extreme. You must spend months inside confined metal walls watching Earth become a pale blue dot. And finally, after months of travel, comes the landing. But landing on Mars isn't like landing an aircraft on Earth, because the atmosphere is too thin to help a ship land on its own. Gliding safely is almost impossible, and this is what engineers call the Mars landing problem. Parachutes alone are not enough. Rockets alone are inefficient. So the spacecraft must combine multiple systems perfectly within minutes. Heat shields, supersonic parachutes, retro rockets, autonomous guidance systems. And if anything fails, the mission ends instantly. This is why engineers call it 7 minutes of terror. Because from the moment a spacecraft enters the Martian atmosphere, it has only around 7 minutes to slow down from hypersonic speed and land perfectly on the surface. So, during those 7 minutes, everything must work flawlessly. But landing on Mars doesn't solve the problem. It's just the beginning, because surviving on Mars is the ultimate test that will decide whether humanity becomes a multi-planetary species or dies trying. We are going to explore the brutal reality of surviving on Mars in part 2. Subscribe to the channel so you don't miss out.